Welcome back to another Python for Beginners YouTube tutorial. I'm Harry Norton, this is Harry Does Data, and I make data science videos here on YouTube. In this video, we're going to be taking a look at lists. Lists are another built-in data type used in Python, and they're different to integers, floats, and strings in that they're used to hold collections of data. Lists store collections of data in a particular order, and they enable you to keep your data together, condense your code, and perform the same methods and operations on multiple values at once. Lists are created using square brackets, and you separate your elements of a list using commas. So, here's an example. We define an object with the name planets, and we use the equals operator to assign a list to this object. We start our list by opening with a square bracket, and then our first value in the list is the string Mercury. We then separate our values in a list using a comma, so the second value is the string Venus, the third is the string Earth, and the fourth is the string Mars. We then close our list again with a square bracket. We might have a second list called rotation periods, and this tells us the number of hours in a day on that planet. So for example, Mercury has 1407.6 hours in a day. Anything can be stored in a list, including integers, strings, floats, variables, and other lists. And not everything in a list has to be the same data type either. So you could have a list containing lots of different items, such as this. We could have a list called randoms that contains the first value as a string, the second value as a string of the number 2.72, the third item as an integer value, 199, the fourth item as another list of simply the integer values 1, 2, and 3, and the fifth item is another object, our planets object that we created earlier, which is also a list. So if we now run our program, we'll assign this list to the object planets, we'll assign this list to the object rotation periods, we'll assign our randoms list here, and then we print our randoms list. So here we see all the values within the randoms list printed to the console. And you can see that when this is printed, the planets list is actually printed out in full. So now that we've created a list, we need to know how to access the individual items within the list. And you can access the items in a list using its index or position in the list. In Python, the index values start at 0, so if we want the first planet in the planets list, we'd have to use the value 0. So to index a list, we take the name of the list, so planets, and we use the square brackets after this, and put the value of the index that we want. So if we put 0 in the square brackets, then this will return us the item at index 0 within the list, which is Mercury. And to demonstrate this, we'll simply print this value to the screen when we run our program. So now when we run, we'll see that Mercury is printed to the screen. Just to demonstrate the indexing a bit more, we can change this to 1 and run again. And you'll see that we get Venus, the value at index 1 in the list. If we go for 2, then this will give us Earth. And if we go for 3, then this will give us Mars. This convention of the first item in the list actually being at index 0 can often be a source of errors in your program. So this is just something that you really need to bear in mind when you're writing code, and is often the first thing you'll check if you're getting errors. We can also access elements from the end of the list using negative indexes. So for example, if we want to access the last element in the list, we could use the index -1. And if we run this, planets -1, then we'll get the last element in the list, Mars, printed to the screen. Again, we can do this for -2, and we'll get Earth, -3, and we'll get Venus, and so on. When we access individual elements from a list like this, they can be used just as any other variable would be. For example, what if we want to know the ratio of Mercury's rotation period to Earth's rotation period? Well, we could define a variable called numDays, and we'll assign to this the result of an operation. We'll take the list rotation periods, and we'll take the first value in that list, which is Mercury's rotation period. So we want the 0 index. We'll then divide this by the same thing, but for Earth. So rotation periods at index 2. We'll then print the value of numDays to the screen. Now when we run our program, we're assigning our two lists, planets and rotation periods. We're assigning a new object, which is the result of 1407.6 divided by 23.9. We then print the value of numDays to the screen, and you'll see that this comes out at around 59 days. So 1 day on Mercury is equivalent to 59 Earth days. Something else that we might want to do is modify the items within a list. Once you know how to index the element in a list, modifying that element is really simple. You simply have to index the value as we just learned, and then assign that a new value. So, let's first print rotation periods 1, and then we'll take rotation periods 1, and we'll assign it a new value. Now originally, Venus was a negative value up here because it rotates the opposite way to the other planets. But let's say that we don't care about the direction of rotation, we just want to know how long it takes. So we'll simply reassign this value as 5832.5, and then we'll do this print statement again after our value's been updated just to demonstrate what's happening. So if we run this program, you'll see that originally this first print statement shows that the value of rotation period 1 is negative 5832.5. We then reassign it, and when we print it again, we no longer have the negative value. You may also want to add elements to a list. There are many ways to do this, and you may want to add data to the end of the list or somewhere else in the list. The first way we're going to look at adding data to a list is through appending it. Appending allows us to add data to the end of a list, so let's suppose we want to add another planet to our list. We have the first 4 planets in our list. Let's add the 6th planet from the Sun, Saturn, to the end of our list, and we've purposely missed Jupiter so that we can use an insert statement later. So, to append something to the end of the list, we're going to name the list, so we have planets, and then we're going to use an append method. The way you do this is by putting a full stop, and then typing append, and this is the name of the method we're using, and then we type the value that we want to add to the list. And you'll see here that we get a little hint that the append method appends an object to the end of the list. So, let's add Saturn, as so. And then we'll print planets afterwards. So now when we run this, you'll see that once we print the list planets, the 5th value in the list is Saturn. Now similarly, if we want to insert a new element at any point in the list, we can use an insert method. The insert method takes 2 arguments instead of just the 1 that we gave it last time. The first argument is the position in the list that we want to insert the object before, and the second argument is the object that we want to insert. So, let's make a new statement. We'll do planets, and our new method is an insert method. So we're operating on the planets list with an insert method. We want to insert our new planet before Saturn. So 0, 1, 2, 3, 4. So we want to insert it before the index 4 position. And the new planet we want to insert is Jupiter. So now when we run this, you'll see that we now have a list: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Now that we know how to insert elements into a list, we may also want to remove elements. There are several ways we may want to remove elements from a list, depending on if we know the position or value of the item that we want to remove, and whether we want to use this item once we've removed it from the list, or just discard it. If you simply want to remove any item from a list and you know what position it is in the list, then a del statement is the simplest way to do this. Del is a keyword that can be used to delete any object, so let's say Mars has been destroyed and we want to remove it from our list. We can access Mars by index 3 and use the del statement to remove it. And now that would look something like this. So first we'd have our del statement, and then our object is simply the 3rd value in planets. So planets, and then index 3. And now if we run our program, you'll see that the new list does not contain Mars. We will often want to use the value that we've just removed from our list, and the pop method allows us to do just this. The pop method removes the last item from the list and returns it so that we can use it for something later. For example, we could assign it to a new variable and print that variable to the screen. So, let's say that each of the remaining planets is being destroyed in reverse order from the Sun. We can pop the planet from the list and use it to print a message telling us which planet has just been destroyed. Let's assign a new variable called destroyed planet, and this will be equal to planets.pop. So pop is a method which is acting on the object planets, but it doesn't need any arguments because all it does is pop the last item in the list and then return it so that we can assign it to the new variable destroyed planet. Once we've assigned the variable destroyed planet, we'll print a message to the screen saying this planet has just been destroyed. To do this, we're going to use an F string. So we'll start our string with an F and then the quotation marks. Now, whatever we put inside curly brackets can be an object which will then be inserted into our string. So let's use the variable destroyed planet. And then the rest of the message will just say has just been destroyed. So what this print statement will do is it will get the value for destroyed planet and insert it in here. It will then print the rest of the string just as normal. So let's run our program. And just as a quick run through of everything that's happened so far, we've assigned a planets variable with the planets. We've assigned a rotation periods variable with their rotation periods. We've done a calculation, which we're no longer printing to the screen. We've appended a new planet to the planets list. We've inserted a new planet into the planets list. We've deleted one of the planets from the planets list. And then we've used the pop method to pop the last planet in the planets list and assign it to the variable destroyed planet. Once we've done this, we're printing a message saying this planet has just been destroyed. And here you go, you see Saturn has just been destroyed. We also print planets, and you'll see that Saturn is no longer included in the planets list. You can also use the pop method to pop any item in a list by indexing it. So for example, if we want to pop the first item in the list, then we could just put the value 0 as the only argument in the pop method. And when we run now, then Mercury will be destroyed instead of Saturn. Another way to remove items from a list is with the remove method. This allows us to remove items from a list if we know what item we want to remove, but we don't know the position of it. So for example, we could use a remove method instead of a pop method, and you can't assign this to an object. We're simply going to remove it from the list and we won't use it. So we'll delete this as well. And now we can remove by name. So let's just remove Venus from the list using its name. And if we run the program now, you'll see that the list at the end that's printed does not any longer contain Venus. One last thing that we might want to do with our lists is to sort them. We may want to sort our planets into alphabetical order or our rotation periods into ascending order. So let's just go back to our original lists. And we'll use a sort method to sort our lists. So we'll take the list planets and we'll use a sort method. And if we print planets afterwards, then we'll see what's happened. So now, if we run our program, you'll see that originally the planets are in the order in which we defined. And if we use the sort method on the list planets, then when we print it afterwards, they're now in alphabetical order. If we want these values in reverse order, we simply have to pass an argument to the sort method called reverse, and we'll have it as true. I will make a video in the future explaining the different ways in which we provide arguments to a method, but for now, all you need to know is that we have a method called sort, and we're assigning it the argument reverse as equal to true, so that it sorts the planets in reverse order, as you'll see when we run the program. So that is everything for the list tutorial. I hope you found it useful. If you have, please don't forget to give this video a quick like and subscribe to Harry Does Data so that you don't miss out on more great data science content.